I can turn the AC off. Fuck it. Fuck it. Okay, no AC. How about that? It's quiet. Alright, let's read about this company. Cadence is a leader in electronic system design, building upon more than 30 years of computational software expertise. We apply our underlying intelligent system design strategy to deliver computational software, hardware, and IP. I didn't know they made hardware. Let's see. That turn design concepts into reality. Our customers include some of the world's most innovative companies that deliver extraordinary electronic products from chips to boards to systems for dynamic market applications. We enable our customers to develop electronic products. Our products and services are designed to give our customers a competitive edge in their development of integrated circuits, systems on chip, and increasingly sophisticated electronic devices and systems. Our products and services do this by optimizing performance, minimizing power consumption, shortening the time to bring our customers' products to market, improving engineering productivity, and reducing their design, development, and manufacturing costs. Our electronic systems customers deliver entire devices such as smartphones, laptop computers, gaming systems, automobiles, autonomous driving systems, servers, cloud data center infrastructure, AI systems, aerospace and defense, medical equipment, and networking products. Alright, let's see what else. Alright, let's see. In order to make our customers successful, our products must handle this exponential growth and complexity without requiring a corresponding increase in our customers' costs. Historically, the industry that provided the tools used by IC engineers was referred to EDA, electronic design automation. Today, our offerings include and extend beyond EDA to enable computational software for ISD across three layers as illustrated below, starting with IC and SoC design excellence, followed by system innovation, and then pervasive intelligence. A lot of buzzwords here. All right, Cadence Intelligent System Design Strategy, enabling end-to-end systems from devices to the cloud. Here are the verticals: consumer, hyperscale, mobile, communications, automotive, aero defense, industrial, healthcare. Design excellence, that looks like an IC. System innovation, that looks like a car of some kind. Pervasive intelligence, I don't know what the fuck that is. Alright, machine learning technology and artificial intelligence enablement, I guess that's like a neural network or something. Multi-level, multi-physics, and computational fluid dynamics. Maybe I'll jot that down. I don't know what multi-physics means, but whatever. Computational fluid dynamics, I kind of understand what that is. 3D IC, high-speed radio frequency design and analysis, system and embedded software. What's up? Thanks, Tyrone. Sorry, I'm just getting all these texts. Some beautiful women who want to chit chat. I have to tell them, no, I'm busy. All right. All right. These tools, IP, and associated services are specifically designed to meet the growing requirements of engineers designing increasingly complex chips across digital, analog, and mixed signal domains, and perform the associated verification tasks, including validation of the low-level software running on the silicon model, thereby enabling design teams to manage complexity and verification throughput without commensurately increasing team size or extending the project schedule while reducing technical risks. The second layer of our strategy centers around system innovation. It includes tools and services used for system design of the packages that encapsulate the ICs and PCBs, system simulation, which includes electromagnetic, electrothermal, and other multiphysics analysis. I think this is probably what they're talking about here. Electromagnetic, electrothermal, and other multiphysics analysis necessary as part of optimizing the system's performance, radio frequency, and microwave systems, and embedded software. The third layer of our strategy addresses pervasive intelligence in new electronics. It starts with providing solutions and services to enable AI-enhanced systems and includes machine learning and deep learning capabilities being added to the Cadence technology portfolio to make IP and tools more automated and to produce optimized results faster. Our software and emulation products also support cloud access to address the growing computational needs of our customers. E4, C5, knight of 3, E6, Sicilian defense. Really interesting that you know this company. All right, computational fluid dynamics. They acquired this company called Numika, a leader in CFD technology. That's computational fluid dynamics. And Pointwise. Hey, Fonta. Just looking at a software company called Cadence. I also have some some code up here. Maybe we can switch to that. Do you know much Python, Fonta? You had a little investing club in prison. I had two, actually. Cool. All right. Yeah, I don't know why the CEO left. It's a good question. Just going to grab the balance sheet real quick, and then we'll go to some programming. Looks like $3 billion in revenue. The company's worth $52 billion. Unbelievable. That is unbelievable. He was at Magma before, which somebody mentioned. I think it was E4 who mentioned Magma Design Automation. Really interesting. Let's quickly look at some financials. Well, they're growing like a weed. They had $2 billion in revenue just a couple of years ago, so now they have $3 billion. Won't be long before they have $4 billion, if they don't already. And I think the profitability is quite good. Look at the stock, though. It's gone in just 6 years, it's been a 7x. Woo! Holy moly. Custom IC design. Alright, here come the financials. Cash. Cash money. Cash shmoney. Okay. Debts. Okay. And we're done. Alright, so what we were doing a minute ago, or a couple of episodes ago, maybe is the best way to put it, is we were making an actual Bitcoin, just our own Bitcoin library for fun in Python. And we're going to continue to work on that. Amazing. Cadence is slightly bigger than Atlassian and a little bit bigger than Autodesk. Really big company, really successful. Part of the reason is look at the profits. Around $1 billion in profits, a little under $1 billion in profits. They're probably around $1 billion in cash flow. Yeah, as I predicted. So call it 50 times, 45 times earnings, which is about fair given the massive growth. Really cool. Cool story, cool company. We'll look more at them later. All right. So what are we doing here? We'll call it NumPy practice. And we're practicing NumPy with I thought there were some files here. Yeah, there's one. We wrote 20, very small amount of code here, just 20 lines roughly. We're having some fun doing some analysis and comparing our code to a different library called Base58. And so we're able to take a private key, a public key. We made the Base58 array, which was funny because we couldn't get the right answer, and it was actually capitals before lowercases in ASCII, so we messed that up and quickly found the result. We defined this function to convert Base58 to decimal. We made a converter, pretty cool little for loop here where we just sum all the Base58 values, and yeah, so we actually, it's pretty neat here, we just get the index position to give us the answer for Base58. So really simple, really simple. Now we're going to get a little bit harder, and hopefully I have my friend Fonte's help. Let's see if he's still here. So we're actually going to start to take we're actually going to review how do you go using ECC, how do you sort of develop a Bitcoin private key. And so I think we could do that with a decimal. I'm trying to turn my mic up. Let's see. Can you guys hear me better now? Yes, no, maybe so. Yes, no, hello. Much better? Great. Good to hear. Glad to hear. All right. Cool. So what we're going to try to do, it's not going to be easy, and again, I would love to have my friend Fonte's help, although we didn't need his help last time. um, is we're going to try to figure out how to make our own little Bitcoin. Hey, Nicholas, I didn't get to an answer for BSX. We're going to make our own little Bitcoin library. Too loud now? You guys are killing me. Any good now? A little better? No? Maybe so? Perhaps? Okay. So anyway, we're going to try to make a Bitcoin, base 58 is is what we're using here for in essence, we're trying to translate these private and public keys into decimal numbers. But where do we go from there? Why is this useful? Why is this going to be interesting? Well, I'm going to find the Bitcoin ECC. Let's find out here. Bitcoin ECC protocol or something like that might give us an answer. And I recall from my prison web browsing that there's a Bitcoin wiki. And again, I'm still waiting to see if Proof of Life from Fonta would be helpful to have his help here. Aha, here it is. So this is an elliptic curve called sec p 256k1. There's bitcoinwiki.org. This will be a fun project. All right. So let's see here. Okay, so this is just the sec p 256k1. We can implement that, I think, fairly easily. I think the bigger question, is this the same project? No, looks like slightly different projects. Alright, so what we need to figure out is how do we use ECC, and then we're going to use a SHA-256 as well. But the important thing is that we start with ECC, not with SHA-256, and I think that's a big misunderstanding when it comes to Bitcoin. So let's see if there's a... How does Bitcoin work? That is the question. Let's see. There was a good... Okay. Nearly every 256-bit number is a valid ECDSA private key. Any 256 number from 0x1 to 0xFFFFF is a valid private key. The range of valid private keys is governed by sec p 256k1. Okay. Let's see here. Let's try something different. Let's try private key elliptic SHA-256 public. Let's try something like that. Again, we're getting back to some of the same points here. Keep getting a bunch of messages. Let's see here. All right. So let's see.
Yo, what's going on? How we doing? How we doing? Can we hear me okay here? Hello? Hello, can we hear me? We can hear me okay.
I'm in a
What does Zest have?
chat group here, but try to.
I don't think we can hear me okay. We good? We good?
We don't want to do two things at once, do we? Then we'll end up doing no things at once. Alright, so it looks like this will get us some of the way there. And this is pretty cool because there are not many places where you can go from private key to public key without, you know, just using a bunch of libraries and not understanding what the heck is happening. So this looks like it actually will go from point A to point B.
I think warranted.
All right.
Yeah, well, it's also just like, it's like, if something's stressing me out, it needs to be worth stressing about, and like, this is not
Right.
it. So like, it's like whatever.
Yeah.
Tell your others.
Especially, because it's kind of been like a few things in tandem, right? It's like obviously Noah Smith made his post about Yak a couple of days ago, followed up by the unofficial event last night in San Francisco, and then obviously Rune jumping on the train as well, and then Beth getting watched for 12 hours. That was an interesting chain of events. To say the least.
Yeah, and then also kind of realizing that like there are some people in the group chat that are just kind of and like
Yeah.
and it's like wait a second, like I don't want to be responsible for like these, you know, some of those people.
Yeah,
right?
like I was it's interesting in a different chat I was talking to both Korn and Novus about this, and like obviously Novus mentioned that like more rigorous.
What's up, Orion? Sheepia.
Warranted. But at the same time, it's like, you know, it's tough. It's tough, right? When something is so new like that, to really.
Well, yeah, and I mean, I think that's sort of like my thing, right? Is that like when we started the group chat, I was very, very anal about who got added, and then for various reasons, I was no longer the admin of the group chat, so things just sort of went from there. But at the end of the day, it's like someone, and like someone who's not in the group chat can just add Yak their name and start being like fucking insane, and then that sort of gets linked back to us, which like. And maybe in Repeat's that was just before, we're like maybe like he has a fan or something, and the fan does something like
Shore's
anyone
quantum computing is
who wants to attack will
is a
connect
bit
it.
different from
And
what
there's not really a good
you're
way
asking,
to-
but I think
Right. Yeah. Absolutely.
other than to just not give a fuck, but like I am not in a position to like be that right now. So
Yeah. Totally. Yeah. Especially when I think like neither four of us.
okay. So anyway, public keys and signatures are just points on an elliptic curve. Okay, if both of these points are created from the same private key, there'll be a geometric connection between them that proves that the person who created the signature also created or owns the public key too. So we have some specific parameters for sec P256K1. So here's, of course, the famous elliptic curve. So A is 0 here. So this is y squared equals x cubed plus 7, in essence, right? Yeah, I just threw some shampoo in there. I did get a second monitor, and he's right, Albanians never go bald. When's the last time you seen a bald Albanian? Alright, so this is a prime field. Alright, number of points on the curve we can hit, or the order. And the generator point. Prime modulus is just a number that keeps all the numbers within a specific range when performing mathematical calculations. It's a prime number. This is a really cool site if anybody wants to check it out. I read a lot about this stuff in prison. There are a few mathematical operations you can perform on points on the elliptic curve. The main two operations are double and add, and these can be combined to perform multiply. These operations are the building blocks of ECC, and they're used for generating public keys and signatures in ECDSA. Modular inverse, double, add, and multiply. All right. Before being able to perform double and add operations on the point curve, we first need to be able to find the modular inverse of a number in a finite field. Bear with me. You see, there's no actual straightforward division operation in ECC because all the mathematics take place in the finite field of numbers, right? In finite field, there is no division. You can multiply by the inverse to achieve the same result. Makes sense. You see, this is sort of like a base 58, or modulus 47. 29 and 13 are multiplicative inverses. You can go backwards to the number you started by again multiplying by the inverse of the number. This always works when you have a prime number of elements in the field, like 47. Prime number cannot be divided by any other number, so it will distribute the results from modular multiplication back across each of the numbers in the field evenly without repeating and missing some numbers. So by using the prime number as the modulus, you can guarantee that the number in the finite field will have a multiplicative inverse or a quote-unquote division operation. Obviously, this is a confusing first step into elliptic curve math, but think of finding the inverse as a basic tool of modular arithmetic. Not all programming languages have a built-in modular inverse function, though, which is why you have to implement one yourself. So this is Ruby, and I don't know Ruby. But this shouldn't be too hard to figure out. We could look for modular inverse in Python, though.
to
12 years ago, this question was asked. So it looks like we have a simple answer here that okay, pretty straightforward. This is Python 3.7. And we just need some numbers to test it out. let's see here.
big, but like some minor changes to the way some EA organizations tweeted, or like there's been like evidence of
Okay.
some of the accounts, and I don't know. What do you mean by that? Yeah, because
So what we'll try to do is we'll try to do. Does Python take multi-line comments? I just sworn Python has multi-line comment. Anyway, let's try this. Triple quotes, that's what I thought. Alright, so let's see if we can get multiplicative inverse. So let's pick a prime number like 17. X and Y are our numbers we're trying to inverse here. So let's see, y equals 12, and let's just say x equals 5. So let's see, y equals pow x minus 1 p. Let's see, what do we do here? Printf. Just print. We have a terminal in here, right? We can just run this. Y is invalid. So let's see, let's print this. It's sort of silly. We can't just print algebra. Alright, so this will return 7, which I guess is the multiplicative inverse. So let's see, x to the y mod. Is there a modulus for Python? Python modulus. Modulo. Okay, so let's see, print. Let's see, what are we doing here? 7 star 5 modulo p. Is that right? Let's see, that'll always equal 1. Great. Okay, that sounds right. Okay. But it's telling me y is 7. I don't play CSGO. I feel really stupid right now. Let's try this. that makes sense, right? 15 times 12 is 60. 60 mod 17 is 9. Why is 60 mod 17 9? Let's see. Well, 17 times 3 is 51, so you need 9 more to get to 60. 5 times 12 is 60, right? So mod 9. Okay. So now let's find a situation where x times y is mod 1. So let's see. There we go. 5 times 7 is 35. Mod 17, right? It's 1 because 17 times 2 is 14. Alright, so 5 times 7. Okay, so now power of 5 to the negative 1, 17. That's 7. Okay, so that is the modular multiplicative inverse. Right. Y is the inverse of xp, which is 5 mod 17. Okay, so we have a formula here that will work. K to the negative 1 is what we'll call the modular inverse of k. Fascinating. So we need to define, well, we could do a couple things here. We can actually make this a, we'll call this MMI. And MMI will take two variables and it'll return how x negative 1p, right? So that's the MMI of x and p. Then we're going to also define a new function called double. That's probably a reserved word, so we'll just call it double point to be safe. Okay, so now point has two properties, x and y, I'm guessing. So maybe we'll just make that explicit. Instead of point like being some kind of object, we could just say x and y. And there's no, this is JavaScript syntax, so we got to get out of curly braces. Thank you for mentioning that. Very nice. All right. Thanks, Jordan. Big shout out to Jordan. All right, so slope. Oh, so maybe it is going to return x and y because we have to return this object. So what do? Do we make that an array? Do we want to make that a list? How do we want to do that? List? as a list. Python can return multiple values, but do I want to return them as a list, or can I just do x, y? All right, let's try that. Slope is 3 times x to the second plus a. What is a? A is a the elliptic curve a? Because then it would be 0. So we could just do that. 3x squared is a minus 2y minus 2 star. This is gen y. Or is this point y? This is going to be point y. Alright. And this is all modulus p, which we'll make this p. Okay. So translating a little Ruby here. And because we don't have a division, we're going to have to use inverse. This is bizarre to me. Are we defining x from gen x, I think, here? So now we have to return xy. Is that going to work? And now can we try double point 5.5? Will that work? Okay, we've got two very big numbers. That looks like an elliptic curve point to me. So our goal here is that we can make a key, a private key and a public key. I'm not even sure we need the digital signature. Public key is just the generator point multiplied by your private key. Huh. I guess we probably didn't need a bunch of that stuff we were doing earlier. D times G equals Q. Well, you would think the public key would be, if D times G equals Q, this gives you a point. We still have to convert Q, that point, into a key. Right? Here's the public key, which is a point on the curve. Convert each coordinate to hexadecimal. Okay, so we get, and then what, we just stitch them together? Looks like it. Right, you see that? That's X and that's Y. So the question is, how do we multiply these points? I don't think it's straight multiplication. Here's the private key. The generator point is gen X and gen Y. Here's gen X, here's gen Y. Okay, so here's the multiplication. Double and add, that's why we're creating these. Add. So we have double. Let's try the add function. Alright, there's an if statement here. I'm not an expert in Python if statements, so let me take a look at some other places in my code. No, I'm going to need an example. I think it's just if. This might even work the same way in languages. In this language, if x equals y, return double xy, no, double of x. That's it. Wait, when I say I'm not an expert, I don't know how to do it. That's what I'm really saying. Okay. So this is simple slope. Point 1, point 2. Oh, I see. We're sending in two. Values here. That sucks. Okay, so this is point 1 of y and point 2 of y. So this is point 1 minus 2 divided by x minus a. There we go. Modulus p. Okay. This is a new x, maybe. Return x, we'll call it equals slope to the second power minus a minus b. Modulus p. Okay, let's try that. Let me try something else. Okay, seems to be an error going on here. So we got slope, which is some crazy number as it should be, squared minus a minus b. Do I have this right? 0.1x and 0.2x, right? Okay. That's, oh, I see what I'm doing here. 0.1x is x, 0.2x is a. So this is x minus a. Okay, that might work better. Okay, still no. Extra parentheses. Is maybe, let's see. Oh, I think I have to implement this differently. Slope equals point y minus point y inverse. Let's try this inverse. MMI of x minus a p. What am I doing here? Multiplied by MMI. Okay, let's try that. Sweet, we got it. Okay, now that we can add and double, we can multiply. Once we're done with multiplying, we can do the whole Bitcoin thing. So let's see. Point is G. Okay, and then I guess we're gonna what, do Gen X, Gen Y? Create a copy of the starting point. I don't think we need to do that. Convert integer to binary. Okay. So we have to do a binary. This is a little confusing, a little frustrating, in fact.
We have to go through these rough times, even if because of like exploring possible greater future world. So I think I think to borrow a word from EAs, it would be a bit long-termist to do so.
Yeah. Yeah, and the rough times, well, they'll be in the metaverse, it's not like, I don't see iRobot, like Will Smith style, anytime soon. It's just a bunch of text and pictures. So the answer is to channel Tyler the Creator's tweet from 2012. How is cyberbullying real? Just turn the screen off. If you're not familiar with that, I could probably pull it up. I think it's still on the timeline. But the point is
saying if it's real, we'll turn off the GPUs, turn off the screen.
Well, turn off. Yeah, turn off. Well, I think the GPU should run, but like if you're offended by like Tay AI or like whatever the like version of that would be today, if we just unleash the floodgates of like just all of the best models we have drop pre-trained, kids with GPUs just learn how to run inference with them on fucking Windows subsystem for Linux and just go crazy on the creative generation. A lot of like disgusting, horrific, pornographic stuff will emerge, but also a lot of beauty. So it's I have one of these, like, one of my kind of core beliefs is that like
Well, that's
the
pretty easy.
metaverse, the internet, like just is not real, or if that's too strong a point, it's certainly secondary to base reality. And so I don't treat it with like the same I don't treat it seriously in a way. Like, I treat y'all seriously because it's like a phone call, you know what I mean? But it's like people like are real scared of information today. You know what I mean? In a way that is kind of baffling to me. And maybe it's just because I've been on the internet a long time and I've seen a lot of things, but I don't know. It's interesting to see how people are perceiving the DALL-E stuff, the GPT stuff. Particularly, I'm unfamiliar with like how this stuff works, but people that aren't, are like, oh my god, like AGI is so close, but like, let's differentiate between, if there's an AI that like, just posts on the internet, it's like it's not as bad as like iRobot. You know what I mean? It's like people are really afraid of this stuff for no reason.
It's just big data sets. Big data sets.
Yeah.
Yeah, I mean, it definitely. I don't think people are necessarily conditioned to take a step back. I mean, it's we see it in politics all the time, right? I mean, it's outrage for outrage's sake, and this is in regards to pretty much anything. I mean, especially seeing as we as humans now, we essentially have information on demand in real time, all the time, right? I mean, the transfer of information is just so quick, and I think the layperson doesn't necessarily have they don't feel like they even have time to take a step back and actually think, right? I mean, think before they speak, essentially. So, just my 2 cents on that, but I agree wholeheartedly.
Yeah, like yesterday, Adrian Bronson had a race baiting space. Does anime cause interracial relationships? Right? I think that was really funny because it's kind of an endemic of like I actually am concerned how much the metaverse is impacting real behavior, and maybe there's something true to that, but also it's like it's a bit paranoid, or rather,
it's such a small subset of humans.
Like, it's like that's what happens when you're online, too much, or you give this stuff too much weight, Like for myself, I started to road tripped a lot during the pandemic, just like hanging with the boys outside, cashed out in 2020 and
That's right, Fonta.
get my new businesses online. But like, yeah, it's all about we've got to
27.
return to IRL. You know what I mean? Like, metaverse is a prison of our own creation, in a way. So yeah, it's an interesting shift, this year. Just
Looks right to me.
as they say, vibe shift, multiple vibe shifts, but it's just because, and everyone's traveling right now. Everyone's getting their flights canceled. They think that America, like the world's collapsing because, everyone's flying around right now. Also, that there's been some weirdness since the airports, like not enough people. Airplanes, but it's really funny,
I see. No, no, because you're not distributing the subtraction. You're subtracting x minus a.
Yeah, also all my VCs, VC friends undergo complete psychological breakdown. March, I was calling them up. I was like, "Yo, you good, man? It's all, what's happening. The numbers."
I see what you're saying.
And you're trying to get money from fucking Sam Fragman of FTX, but
Yeah.
I think.
Like 2 weeks later, they're like, "Yeah, man, I'm doing some soul searching."
So yes, soul, yes.
I think this is still. I'm just trying to avoid the order of operations changing. So I suppose it doesn't make a difference.
Ultra leopard beta. Everyone was just so long. But it's been an interesting shift, and I think people are just pretty negative about everything at the moment. But again, it comes back to the speed of information, right? Nobody feels like they have the time to take a step back and think about exactly what's going on. So it's all reactionary.
Yeah. Now, one concern I think that I do weigh, just to keep on the EX stuff, just one detail around that I foresee is the whole time on chip situation. I saw that Apple might not even drop the iPhone 14 this year due to open questions about where the whole China-Taiwan U.S. situation is going. And then that also goes for, I believe NVIDIA sources, from TSMC. I heard their new GPUs are coming out. But, I'm just thinking in terms of the GPU supply chain, we need to make sure that is healthy so that, as many ideas can be actually made manifest and expressed through engineering work.
I think it's both. I think there are headwinds and tailwinds, right? The crypto market is kind of crashed now, so it's and also Ethereum is moving to a proof of work to proof of stake. So that makes getting GPU at least way easier. So I'm optimistic on that, and I do think that a lot of fabs are coming online. So we are seeing the South Korean 500 billion investing 500 billion. We'll see in the next 10 years America's fabs will come online. On the bigger nodes, you'll see India's as well as other European fabs come online. So I'm actually more optimistic about the long term, because countries now see this a major security risk, as in we don't want just all of us dependent on Taiwan. So I think
I think it might be there might be just in the next 5 years, or just in that next 10 years. I think even with crypto not doing GPU supply, there's events that have a non-zero chance of happening to sort of derail that. But we'll deal with that when we deal with that. I'm a scalper, so when those GPUs go out of stock, it's me and my friends buying them all up, selling to y'all. So
Yeah, I know a couple people that do that as well. It's interesting. I think if I tend to be with the Vegeta there as well. I actually think the smartest thing that China could probably do is actually wait this out and wait until these fabs come online until they do anything with Taiwan.
Yeah, they need the money too. China's they're really fronting right now.
They're fucked. They're fucked. They are so over levered, and they have serious credit issues. And I mean, we've been seeing this play out over the past year or so. I mean, even longer. I mean, you know, with the collapse of Evergrande, right? I mean, and it's actually interesting that the collapse of Evergrande, you know, I mean, you probably heard about it for like a week, and then it was like, okay,
right,
well,
that could work.
Collapse, right? And then it's out of the news, and it's like, okay, like next thing. But you know, there is like serious and it was proven that was a serious contagion risk. Evergrande was not the only developer to go under, and you know, when you have a lot of their economy built off of the property sector, to have your property sector go under is not exactly a very good thing. And it's happening right now. Like, and so I mean, they're in some serious shit. I mean,
Yeah.
they're in no way economically prepared to go to war with the US. I think if they're clever, they'll just wait this out. Wait for the European fabs to come online. Wait for the Korean fab. Wait for the US fabs to come online.
Yeah.
A lot less collateral damage that way.
Yeah, it seems that like the most offensive thing that they've been doing over the last few decades is the espionage program.
Okay, so I'm going to turn that off just because I have a lot going on. This is somewhat complicated, so let's try this. We made the modular inverse function. That's not too hard. The hardest part here is this multiply point. I'm going to need Fonte's help here. So this multiply point takes in this k number, which is the Koblitz. Let's see what k is real quick. It should be the Koblitz curve, but it might just be what we're multiplying by, right? Is that just the coefficient? It could be. Hold on, let's see. So we're going to multiply the point. This is the elliptic point, gen x, gen y. This is the sec p 256.1. Just try to figure out what exactly it is we're doing here. The generator point is being multiplied by some number k, where you change k to binary. I think that we're comfortable with. Then we're going to do some magic. K is what we're multiplying by, right? Yeah, I think that's right. K is just what we're multiplying by. So if we get 0, we double, and if we get 1, we double and add. So what we need to do is we get this binary point. Okay. So you can see this is 123,123. If you add up, well, this is 1. This is what, 2. No, yeah, this is 2. So this is 3. So that makes sense. Should be about right. Okay, so now we want to split this number into an array of however many digits this is. And this is how you do it in Ruby. So we need a way to split the binary digit into kind of an array of binary strings. So list binary point. Okay, we could try that. Oh, perfect. All right, so now we can take that list and do a for loop. Okay. Let's see, so we could do like for index y in enumerate binary point. Would that work? Let's say print y. Let's see if that works. Right. Okay, that worked. So it's just a for loop. And now we need to sort of do some running mathematics. Ignore the first binary character. So we double, or then double and add. I see, so we double for each one. Okay, I got it. All right, so let's see, we have a running. So now here's my second question. I guess we have to get a list, or what Python calls a list. I have numpy here, or numpy. So I want to save the x point and the y point in some variable. Let's see here. And I want to pass that point, the x and y point, to double, which takes double point, which takes an x and y and returns an x and y. So let's see. Double point. Gen x, gen y, but what returns from double point is current gen x, current gen y. I don't think you could do it this way. Equals double point. Would that work? Does that work? That'd be amazing. What weird syntax, right? Variable 1 and variable 2 is the result of the function of variable 1 and variable 2. Would that work? Wow. So, yeah, we can do it like this. We could just have it keep running, right? Then we could do an if here. If, what is it, y equals 1. We can also add current gen x, current gen y. Okay, and then the point. So what's point here? Point is g. So that's gen x, gen y. Okay. Add point. All right. Cool. So maybe now it'll print gen x, current gen y. I'll do that here too. Let's try this. Okay, looks like elliptic curves to me. And now we're going to return Alright, now let's see if our private key, public key thing works. If these will actually return correctly, because we have private keys and public keys that we can get from like a key generator website, but now we want to make those generations ourselves. 39. What are you saying, Fanta? Why you do this to me? No, I see what you're saying. I see what you're saying. So we have to actually assign this like this, right? I see. Is that what you're saying? Oh, that's why it's not changing it. Now I get it. Now I see. Now I should probably print those again. Still not convinced I have it right. Let me look at add point real quick. Oh, add point does it correctly. Doesn't look like it's adding anything. It's always the same output. If y equals 1, console.log, what am I doing here? Oh, y equals 1. What's the problem? Oh. There we go. What an insidious bug that we have squashed. Okay, we now can create a public key from a private key. Let's try. Imagine this code works. Can you imagine? No way, right? No freaking way. So let's see, how do we print? Print, multiply point. Is this right? Yeah. Will this work? It's not gonna just, is it gonna print the return? Let's see. Alright, well it's not right. This is not the result that we expect here. But we can debug. There's a mistake somewhere. Forgot to ignore the first bit. Probably. Okay, so we got binary point, which we've taken the binary of k. So let's see, where do we index y enumerate in k? So let's see if y. Oh, maybe we just change the binary point equals binary point. What do we do, like this? Oh. Cut one off, is that it? Do I get that syntax right? try it anyway. I'm gonna do it live. All right, didn't work. Is it the other way? Like this? We're gonna do it live. We did it live, it didn't work the second time either. Oh, did we? Oh, we are cutting off one off already with 2. Okay. And one of the things we could do is take Ruby. Is this thing interactive at all? No. I could do a quick Ruby. Try this. Say Ruby live REPL. Ruby REPL. Okay. Try that. What do you guys think? I'm not sure how to reference like the Ruby variables like this maybe? I don't know. Try it. Okay, undefined method X. G.X, G.Y, maybe it's like this kind of thing. I can omit G? That doesn't seem right. But I take your word for it. Yeah, it has to be some star G. This is the X point. Oh, can I could just, maybe I could just put in the number X. Is that what you're saying? Just put in the number Y manually. We don't need to know Ruby now, do we? Wrong over arguments. Word. We look at multiply. Oh, it's already, I see. It is the wrong number of arguments. Now I know what you're saying all along. We get some trashy photos. Yes, we do. She's very beautiful. I think we have, okay, well, it's multiplying it, but we need to print it, right? I don't know how to print in Ruby. I'm hoping this works. Sign up for the full experience. What? Sign up these nuts. Okay, there's the result. Was that what we were looking for? Yes. Okay, so this code works as per okay, this code works. So what we want to do is sort of trace what happens. All right, so let's see here. We can print each step, right? And we'll see where we're going wrong. That should work. Okay. Let's see, print binary the state. Okay. We can print, and we can print as it's coming along here. Print current. We could current before, current after, and current after this. Let's see how that goes. Okay, it's a lot of numbers. Jeez. All right. But the first step let's compare our kind of first steps to their first steps. This looks like too many first steps. Can't even find where I called this thing. Or ran it, I should say. Run it back. Is it here? Is it there? Is it anywhere? It's too much. It doesn't even go back that far. Okay. It's not good. 338. Okay, okay. So our first print is 7665. Okay, let's see here. Maybe I can run it. Let me run it into here. Cool. All right, so it's wrong off the bat, which is probably what I would have expected. So it's putting out the wrong numbers. And so there's something wrong with our first line of code, really. So we multiply k times gen x, gen y, which are global constants. We assign gen x and gen y to these two. Let's get rid of this. We take the binary point. Hey guys, sorry about that. Fonte, you like Tool? I didn't know that. What else do you like? Anybody figure out the problem as well? Misreading point 1 for point 2, is that what's going on? Bug in line 26. Ah, thank you. This is... You want y minus b star mi x minus a p. So that is what it says. No, okay, hold on. 2 parentheses. That's the same thing. You want the whole thing modded. Durr! Durr! Alright. Still not the right answer, I don't think. Oh, well, hold on. Hold on. It's not changing the answer, which is worrisome. Which means, are we even calling this? Okay, it does look like it's getting called correctly. Doesn't modulus take last precedent anyway? I don't know. Let's try. Again, that first calculation is wrong. So we're just going to take step by step. Let's see what happened. All right. Trying to get reoriented here. All right, so let's see. We got the so what's the first print here? We're printing K, which is what we're passing in. Great. Then we get the binary point, which is this, and then you know what? I'd like to see what it looks like before the slice and after the slice. So let me try this. Binary point no slice equals bin of k. Let me try that. Binary point no slice. Okay. All right. So here's the binary point. Do you see that? Do you see the problem? We're not ignoring. See, what would you do without the Shkreli debugger? We got a slice. Do you see that? We got to slice 2 or 3 off. Right, we get to slice the leading 0, and then the B, and then the 1. Crazy, right? Right? Yeah, one of the things I am good at is debugging. All right, we still are getting the wrong number, though. I think we're getting closer. Let's see. Let's go to our website. The debugging skill from when I was a child. What's the answer? 338, right? Okay, so this should be 3 and this should be 952. All right, let's print the instruction set again, or the iterative points. Or, you know what? Oh yeah, let's do that. Fuck it. Don't need this. It is what? Yeah. You called it right. Alright. Let's go to the first calculation. We don't really need all these other ones. Alright, so we got some weird result here. We know this one's correct. Alright, so it should have be 7665, and then that's Y. Oh, is this running off the screen? I think this is running off the screen. I don't think this is the exact thing. You think it should be 2? Are you sure? Because I don't think it slices off the... I thought you're supposed to slice off... You're supposed to actually slice off one of these things. Because with 2, I think we're just slicing off 0b. I don't know. I think... Certainly not the right answer, because I think we got bugs somewhere else. Go to bed, go to bed. I think we're supposed to ignore the first binary character. That doesn't mean the 0b. Yeah. Alright. Anyway. Alright, so let's see if we can't... let's see what the very first number is. And right, these are just the non-manipulated. So let's see if we can get the first response in Ruby to be correct. Keep saving like I can do something with it. Okay. So that's 550, right? Okay, so 550, 326, and then the next print is as follows. So let me just take this and put it in like a Notepad++ or something. If I only had some place I can just dump some data. Okay. So here's a binary number. This is with the 5 1s. It leads with 5 1s, so alright, here's the generator. Oops. The generator is okay, and that looks right because it's multiplying it, right? So the number's getting bigger, although it seems to get smaller or something. Let's take a look. So where's that print? Okay, we're printing binary, and we're splitting, and then maybe we can actually do this for a stack trace. Keep saving. Oh man. OnlyFans is draining my bank account. I gotta stop. But you can't. Thought Patrol Surveillance Division. We spend millions on OnlyFans patrolling. Alright, here are the 5 1s. Then can we, are we printing the car? We are printing the car. Here, there's 1. Let's see how many, let me see how many loops through. Thought Patrol is a group that I started many years ago. Just don't ask questions about Thought Patrol. Yeah, OnlyFans is going ham. It's that time of the month, maybe, I guess. I signed up. So I thought I was printing the car. Maybe I copied and pasted. Yeah, I think I copied and pasted in the wrong place. perfect. What's going on here? This is different. Oh no, it's printing the car. That's why. First car is character is 1. Just I'm saying car. Next character is 2. So let me see if it goes through 4 of these or 5 of these because it's 5. There's 4. It'll be interesting to see if the next one is 5 or 0. It's 0. Okay, so we're doing that part right. But why are we getting the same numbers? We're getting a slightly different number. Let's see, let's copy what we're getting and see how different it is. It might give us a debug answer. It's not too far, so I think we're missing the double, possibly. We're missing the add. We have the double, but we don't have the add. And let's see how we're doing on Y. Here's Y. These are, of course, the original generator numbers. For all you hacksaws out there. Okay. So this is us. This is the right number. Ooh. All right, let's see. So where are we going wrong here? Oops. Let's see. So we want to look at you know what we can do? How about this? How about we sort of conditionally print based on the index. Alright, so those are the 254 fonts I mentioned earlier. When index is 1, we're getting this result. So what we can do is we can sort of pause there and just print when index is 1. Alright? When index is 0, maybe we should do it when index is 0, because when index is 0, we're just starting the calculation, right? If index equals 0, do this. Okay? And then also here, if index equals 0, do this. Okay? And we could say, after doubling, okay? And then, yeah, let's try that. Alright, so after doubling, we have this. I also want to see what y is, because y is 1 in this case, right? Oh, I think I see what's going on here. We're not testing if y... oh, no. I think we're all right. Let's see here. Let me try this. All right. Index is 0 and y is 1. Y is 1. And I want to know the type of y. I did forget a comma. Thank you very much, compiler. Class is string. Good. Short font, I'll paste my code. Of course. What are we doing here? Let's see. Just paste this. What do we call it? Paste bin. That's what all the hacksaws use, I believe. There you go. Alright, so anyway, let's go. Let's fucking go. After doubling, we get this. And this is, I believe, the final numbers. Let's go to Ruby. So for Ruby, okay, split each do, print current, car, print, we can print after this, so. We may have too many, yeah, looks like we have too much data here for the REPL, the replit. I should really get a Ruby, I have a Ruby interpreter. I don't want online one. Interactive Ruby shell, Ruby, install Ruby maybe? Ooh, maybe you found the bug, Cena. 29. Return X. That's a good question. That is a good question. That is a good question. Do you want to try it? It's crazy, but it might work. I don't think it is. Imagine that works. Doesn't look like it worked. But that could be, that definitely could be the error. But I want to try it more sort of carefully. Just kind of want to download this. Maybe closer than an answer. We're not quite there yet. Let me take a look here. After doubling, I don't know. I actually think I'm right because we're much closer. Much closer to the right answer. Let me see here. Something's wrong. Yeah, this is much closer to the right answer, but that doesn't mean anything necessarily. Yeah, you see, this is the first result. Line 2? Let's see. All right, let's go back to figuring this out. All right, so we got index is 0, y is 1, so we're going to double after doubling, and now I need a good Ruby REPL. That's the problem. So I mean, I could use the Windows but I can probably just do this different way as well. I just don't know what index I'm in. Maybe will it tell us here? Index? I don't think so. Let's try. Okay, so let me see. In Ruby print index for each do. Index each. Is it I? Is it? Trying to get the index value. Like an index number. I think I could do that. Each. Okay, here we go. I see each with index. Let me try that. Hopefully this doesn't mess up all the code. interpreter. All right, 5 zeros here. Is that right? 5 zeros? Print binary. Okay, now do I want to print it again? Or we already did this where we determined it came up with 4. We did, okay. So get rid of this. We've got the index thing now, so we're good there. So let's see, if index equals 0. I don't even know what the Ruby if syntax is. Let's take a look at that. Okay. And then you have to do an end. That's right. Okay, if conditional then something, let's see, print, or is it puts? Print works too, right? Okay, print. Okay, so this should run only once. Okay. Great. Okay, so now we can kind of trace. Print current, right? Okay. Cool. You notice how it only goes through 220 indices, and we went through 254? That immediately makes me wonder. Wonder if our answer is in here somewhere. I don't see it. And it's not going through the right math anyway, so kill that idea. Alright, let's go to VS Code. Okay, let's see. Let's go back to here. See our stack trace. Debug. Alright, so this is the gen x gen y. Okay. This is after doubling. Very important. Right, we had this from before. And so the question is, how do we get here? So we're going to carefully step through. Well, it looks like 2 different numbers, doesn't it? This is Cena's number. This is the correct number. But wait a second. It looks like a mix of both. Looks like Cena's number is correct, but it's wrong for the y number. Son of a gun. This was the original correct number, but that doesn't seem right to me. Confusion abounds. This was what we called the correct number. But I think this is the correct first step, which is to double. Right? So it ends up becoming this number. Hold on. Let's take a look at how this transforms slowly. Right? After doubling and adding, now we're at the correct number. I see. So Cena's math was correct. Congratulations for finding that super bug. Very smart person. But we're not getting the right y number. And in fact, the y number looks like it's unchanged after the first step, isn't it? Oh, hey. Gen x in two places, is that what you're saying? This is the new double point function. Let's take a look. Double point, xy. I don't know, I think the original double point was beautiful. P, correct, yes, that's exactly what I have, Fonte. That's exactly what I have. New x, new y. Are these like immutable? Can we just write over them? Oh, we need the old references. Woo! This is too sloppy, too sloppy. I'm kidding, content. Always throwing shade. Alright, if this comes out right, I'm gonna always remind myself to go a little more slowly and triple check that the code's right. And there it is correct. Let's just triple check that we got that all right, and then we can celebrate. Celebrate good times, come on, meow meow. Alright, let's see. Pretty sure I remember the number was about right. I just need to find the damn window. Open it and close it, there it is. Yeah, there we go, 338, right? Darn it. 338 and 952. 338 and 952. Wow. We did it. We did it. We did it. Yeah, I have Bloomberg Y. Alright, so we did it. We don't actually want to sign anything. What we're really worried about is this. And what's amazing is we just convert to hexadecimal, so I think we could do that in Python with just hex, right? Python hex function, right? Just hex. I think it was Cena too. I think Cena, I don't know if Cena's here or not, but Cena really. Nomad 2. Alright, so we've got something that will get this private key and return a point on that public key's elliptic curve. Right? So now, what we're going to do, and that's just multiply point. So now what we're going to do is we're going to take that public key and we're going to transform it to hex. So let's see, all right. Let's define private key. Let's see, private key in decimal perhaps. Okay, we're going to take that, put that here, do private key in decimal. Okay, we have gen x, gen y. And then what we're going to do is we're going to say public key, pub key x, pub key y equals this. Okay, now we need to hex pub key x, and we need to hex pub key y. We of course have to assign this somewhere, so we're going to assign it to hexed pub key x and hexed pub key y. Okay, now we're just going to print all of this stuff. Pub key x, pub hexed pub key x, pub key y, hexed pub key y. All right. Let's get rid of all this debugging stuff. Alright, so we need to get rid of the 0x leading. So we're going to try to put like slice. How do we do this? I'm screwing this up. Is it splice? I have it right up here. Oh, we just, oh, I see how to do it now. So let's see, this is, we can try 2. Okay, that's perfect. And now we just have to concatenate those two. Will this work? Looks. Let's see here. Yep, looks like it does. Just kill it here. Normal. They are leading 0x is gone, so now we need to concatenate these things. So let's see, combined key equals, should this work? Pub key x plus hext pub key y. Let's try this combined key. Yep, that is the combined key. Cool. So that is the private Bitcoin key. Right? Do we see where it concatenates? I'm missing the beat here. FA. 85, okay. Do you guys see it concatenating correctly? B1. Okay, there, and then there's the rest. Cool, perfect. Looks perfect to me. All right, so that is how we go from a private key to the public key in hex. So we'll call this public key hex, maybe more descriptive. All right, so what good is that public key hex? Can we convert it back to decimal? Does that work? Or is it des? Maybe keeping in line with bin. Python decimal. Yeah, no, we'll have to do the checksums and stuff like that. Add each hexadecimal coordinate to 32 bits by prepending zeros if necessary. 32 bytes. Oh man, it's almost midnight. I have a call at 8 o'clock. So this is X, this is the Y. They're points on a curve. This is the hex point of the curve, this is the hex point of the curve. This is the concatenated, basically, hex point on the curve. But we can go backwards, right? If somebody gives us let's see if we can figure this out. Had each hexadecimal coordinate to 32 bytes, 64 characters. So is this 64 characters? Should we count? Can we count? Yep, sec p 256.1. Yes, indeed, sir. That is it. So what do we say? List? Is it list? Lang, of course, Lang. It is 64. Will it always be 64? Okay, cool. Okay, so let's see. Common prefixes or public key prefixes. Every x coordinate will have one of two possible y coordinates. One is even and the other is odd. Does it make sense to anybody? One is even, the other is odd. It just seemed like they're different signs, wouldn't it? Still got a Millie sitting in my meta mask. I got the whole fucking verse written out, dog. Everybody knows Nick Vaughn. That's my dog in them. Oh, he just sent me the instrument. Oh my, ready to spit. You guys are gonna lose it when you hear this rhyme. What's going on? Yeah, September. Oh yeah. Do you want to fly out for September? Have a release party if you want to come in. Fly in just to fucking stunt on everybody. And we could even do a fucking debut. Oh my god, we could do it live from the VIP section of the club. Like a walkthrough. That's gonna be pretty lit. Yeah, they're probably gonna take me back to jail that night for balling too hard with Nick Vaughn. It is what it is. You gotta do what you gotta do. Take the charges for me, dog. The lads are on tour. Shut the club down. Alright, let's focus. Let's focus on this elliptic curve shit. Why would one be even and odd? Oh, I think they're saying it's even and odd on the basis of